I think your mic is off.
Yeah,
So
you're
mute
breaking you're breaking up a little bit now, just now, but more or
Can you hear
less.
us now?
More or less, yes.
Okay, hopefully the session goes well and nothing surprises us. And is it okay if we record the session?
Yeah.
So without further ado, I'd like to welcome Mr. Sandor Bali from Singapore. So where's your Sandor?
Okay, so I'll just share my screen and hopefully then we will be okay without the technical issues. All right. Can you see my screen?
Yeah, we can see.
Okay. So, hello everyone. Welcome to this session. So, as I was introduced, my name is Sandor. I'm a customer success business partner at Graphisoft Asia. So this means that I'm helping and working working together with our partners in the region, in the West Asia, East Asia region as well, on events such as this one, or BIM implementation, or working with the clients, trainings, learning, an education program, and many more. So today I want to give you a short introduction to the concept of green building design with our tools, with Graphisoft tools. So let's take a look at this. There are actually two things why you would want to start with it and why you wouldn't want to get started with it. So there are incentives and there are deterrents when it comes to green building design. So one incentive could be that it is required by the owner for certification. Another one that is required by the code. It can also be just maybe your own incentive that you want to impress the client that there's an extra service that you can provide. It's also a good argument or a good way to argument against the engineer to have a stronger point to have a more informed design decision. And also, since you can offer this as a service, this can make a difference between other consultants and your practice as well, that you offer this as a competitive advantage. So these are the good parts, why you would want to do it. But on the other hand, of course, we can say that energy performance evaluation, certifications, these are complex things. These are not really for architects. It needs more knowledge in terms of building physics. Many of the architects are more into the design. Obviously, not all of them, but many more want to focus on the art and the design part. So this would also require, in most of the cases, some additional software, which makes it also harder because you have to learn something new. So let's see what we have in this case. So first of all, why we would have to take care of this and why is it important? According to many researches and statistics, buildings basically take care of the overall, then around 40% of the overall energy use. So that's a very large sector, and it's basically everywhere, right? So everyone is involved in the buildings. So definitely that has to be something which we take care of because it affects all of us. So when we look at the building life cycle, there are these different stages, and in most of the cases, we always think of the design part itself. So when you think about the costs, but also when you think about other impacts as well, and mostly it is restricted to the design phase. But actually, even if you just consider that through the design or until the design, you go through the raw material acquisition, the manufacturing, and the construction, which is a little bit, which is after design, obviously. But basically, the bigger part, the biggest impact, the main environmental impact comes during the operation, because that's a very long period of time while the building is going to be in its location, and it matters how it operates, right? So that's the normal life cycle. If there's a way to repurpose it or do reconstruction and demolition, then obviously these are additional stages. But if you just look at the let's build it and use it, then the operation is going to be the most costly part and also the one that is affecting the environment the most. So if we look at this chart, like a time and the cost, primary energy and the carbon dioxide emission as well, then you can see that acquisition and construction seem to be the highest ones, because obviously then it works a little bit more like a factory when we're polluting through the construction works. And in the operation and the planned maintenance, it doesn't seem to be that high for these ones, but it's a very, very long time period. And actually, this chart is out of scale. And and if we look at it, this whole thing in its scale, okay, the building operation, then you can see that in a real scale, this would mean a huge difference. Right? Because here, when we're talking about a building life cycle, typically we're talking about at least 50 years. So even a small peak through 50 years would make a lot of difference. So when we're designing the building, we will have to make sure that our design is based on informed decisions and that we're having a proper low energy building solution set that will support the sustainable operation later on in the next 50 years as well. So when it comes to working with BIM tools, obviously you can do a lot of sketching in these tools. You can do the final documentation in these tools. Even when you're in the construction phase, then you're using these tools. So, as with all BIM related changes, you want to make sure that you do these changes in the early phases because that's when they can have the biggest effect. Because later on, if you do changes, then they can have little effect, but they cost a lot. So if you do these changes in the beginning, then they have big effect, but they are relatively cheap as well. So in our case as well, in terms of green building design, we also want to make sure that in the very early phases, we can support our design decisions. So what do we have in terms of what is the overall situation? Well, according to the International Energy Agency, which is an intergovernmental organization that is proposing policy recommendations and providing analysis and data on global energy sector. The result is basically that the building sector is one of the largest end user sectors, as we could see in the chart with the almost 40% usage. But it's also, and that's a good part, that it's one of the most cost-effective sectors when it comes to reducing the energy consumptions. So that's the good part in this that. And then basically here comes the question. So how can we reduce the energy consumption? What are the methods that we have? Well, one thing is that we mandate it and we require a certification, which means that the regulations and the codes will mandate it. Then the other one will be that we're setting certain standards that are projecting a sustainable future. So this one is totally voluntary if we have green building standards. And the next one could be that we have rating systems that are based on these standards, which is also voluntary. So in this case, okay, what can we do in Archicad, which is our BIM authoring tool at Graphisoft, is that we can have our objectives aligned with these goals. One thing is that we would like to estimate the building's primary energy demand. So primary energy is basically going to be the amount of energy that we load the Mother Nature, right? So that's the overall gross energy that is going to be taken from the environment. So in order to estimate this, we're going to issue energy performance reports. Then when we look at these reports, we want to see what contributes to the energy consumption. So which tools, which design options, uh, having what type of effect. So basically, our tool has to enable us or empower us to be able to evaluate these results effectively. And then basically, when we look at these results, we should have some comparisons so that it's clear that I have a design option 1, I have design option 2, then what should be the decisions based on these reports, right? So I can see that this type of solution has this result and the other type of solution has that result. Okay, so here is again the primary energy, as I mentioned. So basically, this is the amount that is extracted directly from the natural resources. So for example, if you're thinking about fossil fuels, then like the coal that is mined. And then basically, as we transport this energy and as we process this energy, we're going to have energy industry losses and transportation losses. So that will result in a fuel consumption. And then basically when we get to the building, then we're also going to have losses through our actual system. And basically this is how we get to the final energy usage, which is required by the building. So you will see that there are a lot of factors in between the end user energy and the primary energy. So that will also depend on the different regions and how effective our systems are. But here is just one more example on these losses. So again, if you take a look at coal as an example, then while processing coal, 64% of the energy is lost. Then when we convert it to electricity, then 36% is there. While it's distributed, then 5% of this is lost again. So basically, in this case, the remaining part is of the original is 34%. And then also, if we typically take a look at these traditional incandescent lamps, we know that they produce a lot of heat instead of the light. The simple example, and there we can see that 91% energy is lost. So basically, out of the 100%, we get 3% in the very end. So it means that our nature is going to have a huge impact if we're using coal in this case. With renewable energy sources, it's going to be the other way around. But I'll show you later on how these are considered in our tools and in our solutions. Basically, when we talk about the sustainable solution needs and the design phases of the building, or when we're using the BIM tool, then we should be talking about schematic design, design development, and the construction documentation. And basically, these four parts are the parts or the points in the time when we can affect these solutions. So one thing is the early design phases when we're doing the massing, the orientation, zoning, and when we're choosing the building materials, the construction types, composites as well. Then when we're choosing the low energy building design, and then later on, when it comes to the construction documentation and we're thinking about the certification documentation itself, then we can also consider that we are providing the energy analysis model or this building model to an energy an engineer that is going to provide the certification for us. So a building performance calculation software can use this data and produce the standard certification document. And basically, in our case, we can export our BIM model into these formats as well. And as a next step, we're going to have the building energy performance rating documentation in the end. Okay, so I'll show you up until this part, the third one, how and what we can do in our case. So let's take a quick look at our workflow, our energy analysis workflow. So basically, we're going to have our model, which is a design model, traditionally created, basically no extras, other than, exactly the same as you would do it for a regular building plan. You create this model, and then you're going to put information into it which is related to the energy consumption and the energy performance. So this would include building systems. This could include environmental information, climate information, and so on and so forth. And basically, once we have this, then we're going to convert our BIM model into a BEM model, or well, convert the BIM into a BEM, which is a building energy model. So typically, these are not always possible in BIM authoring tools in general. So this is a great achievement in our case, that we can right away provide this, and then right away can export it for further use as well, if we don't want to do the energy analysis ourselves. But if we want to do it and continue, then once we have the building energy model, then we can do a first round of the analysis, which is going to be just an energy performance evaluation, see how the building performs. And we're going to say that this is our baseline design. So what it means is the baseline is the origin of our design. It fulfills what the local code requires, what the local standards require. It does that, but nothing else, right? So it's the bare minimum what is needed. And basically, we can take further steps after this. So we can improve our design. There will be many different ways how we can do this, either by the building systems or using architectural solutions. And basically, once we have the improved design, then again, with one click, we're going to switch over to this improved building energy model and run the energy evaluation once again. And in this case, it is going to mean that we have a design option, right? So we had previously a baseline design, but now we have a design option, one version of the improved design, and we can hopefully compare these and make a decision what way to pursue. And now that we know how it works, if we want to have a certification, then we can export the BEM for our energy evaluation expert to do a standard documentation for it, a certification for it. All right. So what we have here what we mean by model preparation is that here on the left side, you can see that this is our building in the BIM environment, architectural representation, nothing special here. So we're going to do some filtering. You can see that here on the inside, now you don't see the furniture. So basically we can hide all those things which are not relevant for the energy performance evaluation, such as the furniture. We're also going to exclude some of the parts on the outside, not everything, because all the surroundings can affect our results, especially our solar heat gains. And what is also an extra, and you don't really see it for now, but later on there will be some explanations on that as well. You can see these colors here inside. Those are actually representing the spaces within. The spaces, what we call them as zones in Archicad, are going to be very important. because those are going to create the logical connection between the internal temperature requirements or the internal climate requirements and the external conditions. So in a sense, these zones will be the brain in the process. So what we're going to also do is that we have these visual filters, which is also really just to help us to differentiate things visually. But to have this logical connection, we're also going to set up the so-called thermal blocks, which is going to mean that we're going to collect zones and spaces into thermal blocks, primarily based on their function. So you can see that the meeting room thermal block contains a meeting room zone. But of course, it's not only one zone per thermal block. It could be uh, various zones per thermal block. Basically, those zones which have the same function, the same indoor requirements, the same orientation, and the same building systems. Even if we don't know exactly in the beginning what those building systems will be, but we know that they should have heating and cooling, for example, the same type of heating and cooling, then they will belong to the same thermal block. So this can be a simplified grouping, or it can be a more detailed grouping depending on the level of detail in our design. If we have a very early phase and we say that we're designing a residential building, then maybe we just create one huge thermal block with all the residential zones in it, because let's say the 95% of the building is going to be residential zones, and just a very small amount is going to be access areas and storage and something like that, which has slightly different requirements. So in this case, you can see that we have the thermal blocks zones were collected into it, and we have building systems as well. Okay, so this was the very first setup. So actually, in the when we do these thermal blocks, we don't have to define as I mentioned, I don't have to define the building systems yet. We just have to have the hunch that they belong together, right? So this is still very much an architectural approach. No need to have an MEP engineer in house for that or such. The next thing which I mentioned, that I'm going to put environmental related data into my model. So what this means is that I will set the project location. This is also done by default, typically for every project, as the architect would do that. So it means that they will provide the coordinates. And if we're using the energy evaluation part in Archicad, then basically we can choose the climate data, how it is going to be provided. In our case, there are two options. One is that we're going to take the climate source automatically from a server. And here you can see these two options. There's the Strusoft Climate Server. Basically, Strusoft is the provider of the engine of EcoDesigner. So they are the developer of the original engine. It has Strusoft has its own energy evaluation software, and the engine is also part of Archicad. So they also provide climate data. If we want the automatic version, then based on the location coordinates, Archicad is directly going to get the climate data from Strusoft server. If we would like to fine tune it, or if we would like to use a more standard option, then we can choose to have the second option to use a weather file. So typically these are these EPW files. This is Energy Plus weather files, which is basically available online quite openly, quite widely. If you go to the typically one resource which I used previously was from U.S. Department of Energy. And they have all kinds of weather files for all global regions. So basically, Energy Plus is also an energy performance simulation tool, and the EPW format is their file format, but it's used as a standard in the energy is used as a standard by energy simulation tools. So it contains a lot of information and comprehensive weather data, including the temperature, the wind speed, the direction, solar radiation, humidity, precipitation, and all these things. Right, so this is going to define what is going to be our climate where we have our building. So this was the main dialogue. Environment settings, climate data takes us here. And then if we're done with the climate data, then we can also define a lot of other settings, which are mostly location dependent. So here it's good if you have a basic knowledge of these. Or if you have an engineer who knows these values locally, or if you just try to look them up. But even if you don't know them, then keeping them as the defaults will be still better than using wrong values. So basically, one thing that you can set is the grade level, so how the environment is compared to the building, basically how much it is, the zero level, how much it is from the ground floor, is 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 a theoretical one, and then you can put in a number, or if it's modeled by the Archicad mesh tool, the terrain tool, then you can choose that part. Soil type, you can use your best guess. Surroundings, ground reflectance, you can use some good guesses here. And for the wind protection and horizontal shading, you can see also the wind strength and the protection. Here, as we set the protection, it is going to change this diagram. So how much it is protected in the different types in a different direction. So here, for example, we can see that we have the least amount of protection for the biggest wind speed of the southwest. These ones about the wind protection is not going to consider what is actually modeled. So, or what is the actual environment. It doesn't know what is beyond the building, especially if the environment is not modeled. So here, you knowing the environment nearby will have to choose these options, that whether it's protected, partly protected, or unprotected. Okay, but moving on, okay, the next one would be the energy-related inputs. As mentioned, the thermal blocks. There are different types of views in the model, and basically what happens here is how we assign the zones to the thermal blocks. So you can see that we have a view which is only showing the zones and not the building itself. And when we select these zones, they can have a different color highlight. And also when we select the thermal blocks, they can all get highlighted as a group. So basically, this is a visualization that helps you to make sure that all the zones will collect it into groups. It's not just the visual part where you can select it, but this is something that makes it easier as well. Another interesting part in terms of the inputs is going to be the requirements. So what do we want to achieve? What is the climate that we want to have internally in our zones, in our spaces? So depending on what type of thermal blocks we created, we need to choose how those thermal blocks operate. So what is actually happening in those thermal blocks? So what is the function? And for example, in this case, you can see that I can choose an operation profile that is a meeting or a conference or seminar room. This has predefined values. We have quite a long list of defaults, and probably it is good to use those values if you don't know any specific uh, differentiating factors in those ones, but it is going to tell you standard values for the human heat gain, the hot water load, and the humidity load. And basically, once you have this option, or once you have this selected, what is the function in that space, then you can set up daily schedules. So what this means is that it's not necessarily just work days or non-work days. It really depends on your setup, how you define these. But in these daily schedules, you are going to have this set up on the right side, where you can set up what is going to be the minimum and a maximum internal temperature, what is going to be the occupancy count, what type of equipment and lighting we're going to use. So this is going to add to the internal heat gain. And you can see here, there's also time a time editor basically. So it's very nicely, you can select these time periods and then change the values. So it means that from 7 a.m. in the morning till 6 p.m. In the evening, we want to keep the temperature at between 20 and 26 degrees. And then after 6, it's free free flow temperature. So basically, we don't care about the temperatures. We don't want to regulate it, right? And basically, this is what we have on a work day. On a non-work day, basically, this part would be taken out. So on a non-work day, we would just say 20 to 26 degrees is not a requirement. So it could be any degrees, right? So the more specific we can define these requirements, the more accurate our energy evaluation and demand calculation is going to be. I think it's a very visual and very easy to set up thing. Again, if you consider that you don't necessarily have to know all the actual values because there are a lot of defaults, then this one is a quite easy to set up option here. Okay, so when it comes to the building energy model generation, okay, what are the two parties that who are the two parties that are involved? One is Archicad, and the other one is going to be us, the architect. So Archicad is going to give us the building geometry, obviously because we have the BIM model. We also define the building materials with physical properties and physical attributes. That's very important. So we're not just saying that we have an element that has a hatching and we say that it's brick, but we are going to have actual brick physical attributes. It is also going to generate the building energy model using the zones as the space boundaries. So the architect at this point will have to check these structures and make sure that these are actually the right ones selected. And we can also run solar analysis on our openings. So moving on, in our energy evaluation settings, you can see that this dialog, now it has been enlarged, and now from the thermal blocks tab, we moved on to the structures tab. Basically, this gives me a list of all the structures which are around our the spaces, the zones, right? So everything that is a boundary to my spaces, that the space is touching, is going to be listed here. And you can see the areas, thicknesses, and also values, U values here, infiltration values, and solar absorptance values. These are editable, and in many cases, obviously, you would not necessarily know about these values, so you can just keep them as the defaults. What you would probably know about is the U values. And it's a very nice thing. What we can do here is that you can see that in our structures, actually, we have some very dedicated uh, structures. So it means that you can see here it has different skins. So with all those physical properties, definitely it can be considered as a roof slab, as a flat roof slab. So obviously that would have a real U value in our calculation. And what happens here is that it can get calculated automatically. But what happens if I'm in the very early stage of my design and I just put there a structure which has no skins? Maybe it's just a 300 millimeter thick solid geometry, which I will define later. So how can I use this for the calculation if it's not defined? Well, when we are here in the structures part, I can come here to the U values. If you just double click on this line, this U value override dialog comes up, and I can override the U value, which is practically going to mean that I have no idea what is the actual U value of this structure yet, but what I'm going to use here is going to definitely be worth of this and that U value. So I use it as a design base, and all the energy calculation will consider that whatever slab that is, it can perform this U value. So we can use this even in the early design phases with just a simple override saying that we don't know it yet, but it is going to fulfill this. Moving on to the next tab, you can see that here the third one is the openings. It is going to be a very same approach as with the structures. So all those openings, doors and windows and skylights, which are at the boundaries or which are touching our zones, are going to be listed here. And they also have a lot of physical attributes as well. So the thing is that how do we know how they perform, right? So, well, again, the good thing is that we don't really necessarily have to go into too much details as architects, because if I click on any of these, then I can choose the glazing type and I can choose the frame type. And these ones have very specific types here with all their actual U values, the total solar transmittance and the direct solar transmittance values as well. So typically these are those values which we wouldn't really know um, uh, as architects without some research, but we don't even have to deal with them. Just select from the list. Next thing will be our building systems, right? So we are in the early design phases. We created our building, or maybe it's not even the early, maybe it's not necessarily a very early design phase, but we haven't done the energy valuation yet. So at this point, we just did the architectural design. We have no idea about the building systems. We are not MEP engineers, so we don't really know what should we do. At this point, we can do a demand calculation, which means that we can add all the building systems, and everything which we add is going to say not yet specified. So this again means that we don't know what the system is going to be, but we say that it is going to fulfill the demands, the energy demands of our building. So it means that if my heating system is not yet specified, then it means that it can either be uh, 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 local heating or you know, pellet furnace or a renewable heating or anything like that. It doesn't matter what it is, but it will fulfill the energy demands of our building. So at this point, we're just going to set everything as not yet specified. And this is the part where we can run the energy evaluation. in our energy evaluation, this is going to be a PDF. One option is that it's going to be a PDF. The other one is that we can export this already as a baseline design to other energy evaluation tools. But let's just look at the PDF. Here we can choose different types of chapters to be included in the report. And basically, these are going to be the most important values here. An overall U value for the building shell average. I think probably this is very standard worldwide, that there has to be a value that is not higher than this one. Here you can see the primary energy consumption, fuel consumption, the degree days, which is going to be a good indicator whether it's heating or cooling dominated environment for our building. And then you're going to see the project energy balance. And all these where you have the tables, when you have the diagrams, they can be broken down into the overall project, or they can be broken down into thermal blocks as well. And the great thing about breaking them down to thermal blocks is because we can evaluate all these different thermal blocks one by one and see which one is maybe the culprit and which one could be improved. And the rest are okay. For example, this one is very interesting. You can see that here, this is a European project, or it's in the UK actually. So you can see that during the summer time, or from late spring to early autumn, here we have a lot of solar gain. There, the human heat gain, the orange one is basically the same throughout the whole year. Lighting and equipment is also the same because it's the same usage throughout. Winter time, we have actual heating. And what is balancing this one out? What are the losses? Is the transmission through the structures, the infiltration through the gaps, the losses through the ventilation, and also compensating for these extras with the cooling during the summer months. So we can see that here solar heat gain might be too much because we need to cool it down. So maybe we could do some shading here in the summer, and we could also improve our structures so that transmission loss is not that high. So these are just, very quick evaluations here. There is also another page which is really nice. If we go down, break it down to thermal block, we can go to any specific date. So you can see that in the seminars and classes thermal block on 1st of August, 1st of November, and 1st of February, we can see what is the internal requirement, what is going to be the internal temperature that we achieve, and what is the external temperature out there. So it's going to be very interesting. For example, here you can see that there is a very, very short period where we cannot reach right away the internal requirement. So here we have so-called unmet load hours, but it's just 1 hour, so maybe we are okay to deal with this, or maybe we should start heating an hour earlier, right? Anyways, it's not critical, but there are small things like this that you can also read from these diagrams as well. And basically, this is the most important part, the HVAC design data. So as I mentioned to you, we just said that we're not specifying our building systems. So basically everything that you have here as a heating demand, as a cooling demand for the hourly peaks in kilowatts, that is what the system will have to fulfill. So when in the next step we are going to define the building systems, we're going to use these values as the basis of the performance, right? So and of course, then here we are going to use some rounding, because if you cannot buy, I don't know, maybe a furnace, 2.5 kilowatts performance, but you can only buy 5 kilowatts, then obviously you're going to say that the building system will be 5 kilowatts. Okay, so here we are in the optimization workflow. We created the baseline building without the systems. We ran the energy simulation. So that's when we got the demand calculation as a result, and we reviewed the energy performance. So just now how I explained to you the results basically. So now we have to see what can we use as an optimization. Like what I mentioned, maybe we improve the structures and do some shading. Uh, Once we figured out, okay, so let's say we have these two options, then we can execute a sensitivity analysis, meaning which one has the better result? Is it worth changing the structures more, or is it worth doing some shading? Which one makes gives us the better result? Once we have all these, and we will have multiple solutions, then we're going to have a project-specific low energy solution set, basically. So it means that we can have architectural solutions, we can have building systems solutions, and we can apply renewable systems as well. So it is going to be coming from these three different sectors, in a sense. And once we have the solutions, then we're going to put all these values into our building systems data sheet instead of being not yet specified. And now if we run the energy calculation, then it is going to give us the actual energy usage, which we can compare with the baseline building. And hopefully we will see that now, thanks to the improvements, our energy evaluation results are much better. Okay, so let's see what happens here when it comes to the optimization options. So there can be two approaches, right? Active and passive. So active one, when it's not really depending on the environment, but we're doing something that the building, we can do something on the building itself. So minimizing transmission, as I mentioned, improve the insulation, for example. Minimizing the infiltration using better windows and the installation, the quality of the installation, or maybe, for example, if we consider the buildings in the United States, which are more like timber based timber structure with lightweight claddings, those are not really airtight compared to something that is concrete, right? How can we minimize the solar heat gain again with the shading or maybe using better performing equipment? So instead of incandescent light, we could use LED light. And actually, this is the energy efficient resources already. And then the next approach would be the passive, when we are actually not doing something on the building itself, but we try to cooperate with the environment, and this could mean the renewable energy sources. So there is a research from the International Energy Agency once again, and there is a statistical data on different types of solutions in cooling, heating, and mixed cooling and heating environments. So, well, in our case, I guess if we're thinking about Nepal, then probably it is going to be heating dominated. So in this case, what will help is an optimized building form, advanced envelope, passive solar heat gain. So in our case, obviously, and it's in a sense, it is going to be very similar to my home country, Hungary. That if we can use the solar heat gain throughout the winter time, then we can save the heating, solar shading, and here, for example, in the building systems, mechanical air heat recovery would be useful, and later on, photovoltaics for electricity, and even for heating, the solar thermal panels could be used. So probably here you need to think of 3 to 4 solutions, and those which work the best in that particular type of environment, mix and match and do the execute the sensitivity analysis for those. So some of the examples that I mentioned. So energy efficient equipment, you can change here in this operation profile editor, the lighting type, the fluorescent lighting tube to the LED, for example. Or if you know exactly what type of equipment you're using, then you can change the wattage for that. Now, what I mentioned in case of the structures and the materials, previously we just had something that we made up, kind of, or what was not entirely made up, but what was required by the standards, local standards. Let's say the local standard says that the structures have to perform at 0.28, then we want to obviously fulfill that. Now, when we're using the actual structures, then we're going to have certain types of building materials with their own thermal conductivity and density, which physical properties are also defined in our building material settings. And based on these values, we're going to have a U value calculated. We don't have to do anything about this. If we use the default building materials, then the U value is going to be calculated. So right away, we can see if the actual is going to be below or above the 0.28. If it's above, then we have to either change the thickness of the insulation or use different types of materials. Another interesting one is the thermal bridges. So this is very nicely connecting BIM with the energy evaluation. So because you can create these detailed drawings of your BIM model, and if you select a detail, you can choose to generate a thermal bridge, basically a linear heat loss uh, through that detail. So basically in a second window, you can choose where is the outside temperature, what is the inside temperature, where is the ground if available. You need to check if everything has a building material assigned, and then the energy flow and the temperature differences are going to be displayed visually, which you can also place as a drawing into your documentation. So again, this gives you a huge advantage when let's say you have to convince the client that you would want to go with this solution because this is just more energy efficient. So it's very nicely visualizing what are the issues and what are the solutions. But this is just one thing, because obviously if we have this linear heat loss, then we would like to include it in the energy evaluation calculation. So what is possible is that when you have a thermal bridge, let's say one situation that you examined is going to be here listed, then you can choose here as thickness. Basically, you will have to define the length of this situation. So if this detail is the base, the foundation, and it's along 6 meters, then you can define that the thickness in this case is 6 meters. So it is going to be a 6 meter long linear heat loss with these energy flow values, these transmissions and infiltration losses and so on. So this is when you choose to place as a drawing, this is the visual, what you get. On the other hand, we can do this with the doors and windows. So moving on to the next tab, once again, the openings. Here with the solar analysis column, I can just open this part and see how the solar heat gain and the energy flow is going to be happening throughout the year. So basically here we're expecting differences throughout the summer and the winter, and this is going to consider if you have some shading in front of the building. So if you actually physically model something in front of it, then it is going to reflect the results here as well, which is a great thing. Okay, so basically the first thing which we had in case of the openings, first we defined what are the openings that we're using, and then with the solar analysis, we can actually check how they perform. Going back to the building systems. Okay, so now we would like to define these building systems. Ideally, we would like to have an expert opinion here because we can go into very, very detailed characteristics and parameters of the building systems. These you either get information from manufacturers' data sheets or someone can help you out with these. But even if you don't have anyone to help, then there are two options here, basic and expert. So the basic will be much simpler to define than the expert, and it will be just as good to have, an overview of the whole situation. Here you can see one of the options, for example, expert settings for heat recovery ventilation. You can see what type of uh, ventilation it is, supply or exhaust, what are the functions, and what are the different components that are available. And all of these can be configured with their performance. Yes, yes.
So, so how many slides do you have right now?
Sorry, sir, you're breaking up. I cannot really hear you.
How many slides are you?
Okay.
How many
I
slides
can.
do we have
Yeah,
now?
I finish in 5 minutes. Okay.
Can you hear me now?
Yes. I
Okay,
can.
fine. Then
I
we have
can.
a question and answer session.
Yeah, I'll just go in 5 minutes and I'll finish it. Okay. Okay, so yeah, and then for example, also for the ventilation system, you can set up an operation schedule, which is going to tell you at which types or which time frames how it is going to actually operate. Something very similar as the operation profiles, but that was for the requirements, and this, what the operation schedule is going to define how it actually works in a system. You can use the photovoltaics as well as renewables, as mentioned before, and the wind as well for renewables. And for the overall calculation for the simulation, there are going to be these primary energy factors and the costs. These are going to be very interesting because for the primary energy factors, you will need to see, so what are the losses, what are the inefficiencies in the system. So typically, here, when you see that all these fossil fuels, the number is bigger than one, it means that there are losses. Whereas in case of wood, for example, it would be the other way around. This pellet, there should be a loss there actually, because that's not a fossil like that. So maybe this is a mistake here. But anyways, these are ratios or multipliers that relate to the amount of primary energy input, which is required to deliver 1 unit of useful energy to the end user. And also you can see here how the proportion is for the electricity generation. Again, this is all depending on local situation. And then here you can define the prices and the currency. It's really just a text, so it can be any type of currency. You do the energy evaluation at the end, and basically you're going to have a comparison with the baseline building. I think what is really important here, you can see that there's a proposed design, there is a baseline building. If there are some issues, then you're going to have some advisory messages. So for example, the unmet load hours, which I mentioned earlier as well. But here, this is going to be the interesting part, that here is the proposed design, which is using this amount of energy. This is the baseline building, which was using this amount of energy, which is now 500 pounds compared to 3,000 pounds a year, which means that 82% cost savings were achieved with this solution. So I think this is what is really clearly telling you if you were doing it good or not. All right. And here, this is also another comparison. This is an ASHRAE standard test method, so that it means that it is going to evaluate the building in 4 different directions and then create an average for it. This is just how the standard is. And here there's again a comparison table for the different types of energy uses. It's an interesting one. In case of heating, we were not saving, but we were losing because of these solutions. But you can see that the heating usage was so low that even though we lose there, that is well compensated with the 80-90% saving on the cooling itself. Okay, when it comes to the certification, this is what I meant, that we can export it to other energy evaluation solutions through the GBXML file format, which is a free XML schema, and we can use it for other building analysis tools. This is one-click save as option. Here it is in Archicad, and here it is in a GBXML viewer. We can also save to Passive House, which is a German energy evaluation tool. It's basically an Excel sheet, so we can just save into this format as well for PHPP software input. One question is that whether these results are reliable, and this is just where I want to have a very quick outlook to this ASHRAE certified simulation, is that basically there is a standard method of testing, which means that the different types of energy evaluation tools have to run these standard tests, and the results are compared. And actually here we are, it's very small, but EDS, EcoDesigner STAR, the red one, is us. So basically you can see that all of them are very close to each other, more or less. So it means that EcoDesigner STAR provides you the same accuracy as all the other energy evaluation tools as well. And this is just a few of those rating standards and regulations, that are using this standard simulation as their reference. So UK, Australia, Germany, and US as well. Okay, so I hope that this has convinced you that with Archicad and with EcoDesigner STAR, you can make good design decisions from the early phases as well. And with this, I will just hand it back to Mahesh, and thank you for your attention.
Hello, sir. Can you hear me?
Yes, I can hear you.
I hope you heard the words.
No, okay, now I don't hear you.
Okay, so I'm gonna go to the audience, to the participants, and see if they have some questions. I'd like to, first of all, I'd like to maybe I can thank Sandor quickly, but let's ask the questions first. So the questions from here, anyway. It was a very detailed presentation. From anyone. So usually, when we start to do our BIM models, we use the BIM models for documentation purpose, okay? But we can take that BIM model for the energy evaluation as well. So it's not that only you can, when you develop the BIM models, you put the documentation, you put the quantity takeoffs, you do the 3D coordination, you do the classification. There are a lot of things that you can do, right? But it's not only limited to those use cases. So when you have BIM model, you can even do the energy analysis. So that's why even the predictive lines. So just Sandor showed that how you can utilize the BIM model for energy analysis, and how you can optimize the designs, how you can make different changes, right? So let's start swing business to Sandor. From here, everybody is side Sandor. Nobody wants to action. So maybe I can ask one question to Sandor. So Sandor, maybe like how is it being used in Singapore? Like what is the practice of green building design in Singapore? How are the government's regulations push different consultants or contractors to work in green building design houses? And so what is the status in Singapore from your experience?
Yeah, well, unfortunately, it's not there yet. So I mean, there are some certifications, but these are all voluntary. So there is no mandate. There is no, so there are the lead certifications for certain buildings. What is where it's mostly used, or where, for example, EcoDesigner is used, is mostly in Europe. So our UK clients, Scandinavian clients, um, because sometimes the thing is that we need to have very specific local certification formats. So that's actually why we have this option that we can export the building energy model. So I think overall, since everything is really voluntarily, now it's starting to rise that people and designers start to think about, to validate their design from an energy analysis point of view as well. But unfortunately, I see that in Singapore, this for the generic design, it's not really there. So the architects are not spending much time on energy evaluation. I guess it's probably also because, if as long as it's not requested by the clients, it's not mandated by the authorities, then it might seem to be an extra hassle. Uh, uh, and because of you have to still know a little bit about the building physics, architects might be uh, they don't really have the incentive to get started with it. But that's the thing, that once you start to see the differences in your designs and the numbers behind your designs, it can make a lot of difference, and you realize that actually it's not it doesn't require wizardry, or it's not a witchcraft, but there's it's definitely up to a level which you can also manage on your own without being an energy evaluation expert.
Any more questions, guys? So let's ask one more question to Sandor, if Sandor has some time. Because it's Sunday in Singapore and we have been there, taking a lot of Sandor time. And what time is it in there, by the way? It's almost maybe night time there.
No, it's 6 p.m. 6 p.m.
Okay, 6 p.m. You guys have any questions? No? Okay, so no more questions, Sandor.
Is let me
Yeah.
let me have a question. Is anyone how many in the audience are doing energy evaluations now?
How many in the audience are doing energy evaluation now? No one, Sandor.
No one. Okay.
Zero.
And what is their main BIM authoring tool?
Sorry?
What is their main BIM authoring or authoring tool? Is it AutoCAD, Revit, Archicad?
What is the major design tools that you guys use? So what do you use? AutoCAD, Revit, Archicad, maybe some rendering software. So what do you guys use? AutoCAD. Majority is AutoCAD. Anyone use Archicad or Revit? Revit, anyone? One, two, three hands. Archicad, how many? Archicad, one hand, no? Okay. But how can they maybe if they want to try EcoDesigner, how can they download it and try it?
Yeah, well, if they would like to try it, then on graphisoft.com there is on the header there's a try now button. So basically there it needs a quick registration to create an ID, and then they can download Archicad. But yeah, I mean, like, definitely if you know, to have a building energy model, you need to have a model first. So as long as mostly it is 2D CAD, the base, then you can't really do energy evaluation, only in those traditional methods, manual calculations, taking off the quantities, taking off the areas, lengths. So that is definitely a hassle. If you have a model behind this, and in this case, it doesn't matter if it's Revit or Archicad, then you already have a better position, because all those quantities and the envelope itself is going to be provided for the calculation. So yeah, if you would like to try it, then just go to graphisoft.com and go to the try now link at the top.
So you can go to Graphisoft.com and then request files to print software. If you have any questions, you can always contact me. Contact details are also displayed, and also you can Google, Nepal, students also Facebook, and you can contact from there. So maybe let's give a good round of applause for Sandor for his time. I hope you can hear this time, Sandor.
Sorry, come again?
I hope you can hear this tips this time.
I don't hear you.
Okay, it's okay. Okay, so Sandor, so thank you so much for your time. So I guess this is the end of the session. So we have the recording as well. So maybe we'll make it available to the participants as well. So thank you so much for your time.
Sure. Thank you everyone for the attention, and take care. Have a nice evening.
Thank you so much.
Yeah. Bye. Bye-bye.